Hi, this is a short review on finding limits graphically. So what we have here, we have a function that's actually a piecewise function. It's comprised of all these different shapes here. So we have a hole here, we have a hole there, we have another point that's defined there, solid here and a point there, and we have to find all these different limits. So the first question is find the limit as x approaches -4 from the left. So approach -4 from the left, that would be approaching 1. Now we're approaching -4 from the right, so the same location but going from the right, we also approach the same value. Basically what we do is we analyze as we change the value of x, what's happening with the value of y. So as I get closer and closer to 1, here my function is getting closer and closer to, closer and closer to -4, my function is getting closer to 1. The same thing happens on the other side. As I get closer and closer to -4 from the left, my function is also getting closer and closer to 1. So if these two limits are going to equal each other, that automatically means that the limit at the point as x approaches -4 is 1. The value of the function is determined by the point on the graph, which is also 1. Is this function continuous? Yes. As long as these two things both exist and equal each other, you have continuity at the point. Next question is around 0. So we approach 0 from the left. So as you approach 0 from the left, our function approaches 2. So that limit is 2. So as we approach 0 from the right, our function is going to approach 2 as well. So we're looking at the behavior of y as we get closer to a certain value on x. These two numbers are equal each other. That means this limit automatically equals 2. Do we have a value of f of x at 0? No, we don't. We have actually a hole here, so does not exist or not available. Is this function continuous? That's impossible if the function is not defined at the point. Limit as x approaches 1 from the right, 1 from the left, so we approach 1 from the left, so our function approaches -1. As we approach 1 from the right, we haven't seen this yet in this example, we approach 0, because as you follow this heads towards 0. If these two values don't match, this is what we call one-sided limits, then this limit does not exist. The only way you can have a limit here, if these two values are the same, this is how we find if a function has a limit at a certain point. Does the function exist at 1? Yes, it does. We have a point here, right there, 1, 2. The value is 2. But is this function continuous at 1? No, because this limit must exist and that limit must equal that value here, and this limit does not even exist. So no. And now we do the same thing at 3. Hopefully you can follow along. As you approach 3 from the left, you approach 0. F of x approaches 0. As you approach 3 from the right, f of x approaches 1. If these two numbers don't match, this limit does not exist. Does the function exist at 3? Yes, it does. Right there you have a point. It's not hollow, so the value is going to be 0. But since these two values are not the same, and more so this one does not exist, the limit here does not exist. The function is not continuous, and the limit does not exist. We're going to take a look at one more graph with a whole bunch of questions like that. See if it's going to make it easier this time around. So we have this graph. Just so that you can be clear, this is an open circle, this is an open circle, this is an open circle. There is a hole here, this one's closed. So first we approach -5 from the left. So we approach -5 from the left, our function approaches 1. As we approach -5 from the right, this heads towards 4. Since these two numbers don't match, this limit does not exist. Does the function exist at 5? No. And is this function continuous? Well, if the limit does not exist and function does not exist, it is not possible. -3. So let's see. We approach this. I want to remind you there is a hole here. There is another point there. So as we approach -3 from the left, the function approaches -1. Moving over here, approach -3 from the right. So we're approaching from the right. We still approach -1 with f of x. So since this limit and this limit both -1, the limit as x approaches -3 is -1. Does the function exist at -3? Yes, but it's right there, equals 2. And is the function continuous? No. If these two values don't match, it cannot be continuous. Can take a look at 1. So this is what we have not seen yet with this. As we approach 1 from the left, our function goes down. We say it decreases without bounds, so it goes to -infinity. So one-sided limit here on this side is going to be -infinity. The same thing is going to happen when you approach 1 from the left. You're going to go to -infinity. It's going to decrease without bounds. But here's the problem. If we have limits that are not finite numbers, then we do not have limit at the point. There are different schools of thought on that, but one of them says that there is no limit. So the limit here does not exist, as we understand that the limit must be a finite value. You can't have a limit as infinity. And the function does not exist at this point. You have a vertical asymptote. Okay. And is this function continuous? Of course not, because the limit does not exist. Now let's do it at 7. So we approach 7 from the left. 7 from the left, you have this asymptomatic behavior again. It's going to go to -infinity. As one-sided limit, it's fine. When you approach 7 from the right, you are going to approach 0. These two numbers don't match. This limit does not exist. Remember, one-sided limits must equal each other for the limit to exist. A value f of 7 is defined right there. This one is closed, so it is 0. And is f of x continuous? We got a problem here. The answer is no. Okay, so that's how it's done with graphs. I hope this helps.